welcome to True Projects. In this video, we are going to explain about the project entitled as Transforming Education Through Blockchain, a systematic review of applications, projects, and challenges. So before getting into the video, let me give you the brief description about the project. The title discusses how blockchain technology can be used to improve the education sector. The prime aim of the paper is to address the major issues faced by the traditional education data management systems, such as lack of security, data tampering, certificate forgery, and high maintenance cost. The study reviews different blockchain applications in education and proposes a secure online examination and certificate management system. Coming to the abstract explains that blockchain technology is widely used in various sectors because of its security, decentralization, transparency, and immutability. In the education sector, most institutes currently use centralized servers to store students' data like grades and certificates. These centralized systems are vulnerable to hacking and unauthorized data modification. To overcome these issues, the proposed system uses blockchain technology to securely store student exam grades and certificates. Each record is stored as a transaction with a unique cryptographic hash, ensuring that the data cannot be altered without detection. Additionally, the system integrates artificial intelligence to analyze student performance and uses IPFS to reduce blockchain storage cost. Overall, the proposed solution improves security, trust, transparency, and cost efficiency. Coming to the existing system, in the existing system, educational institutes store all academic records in centralized database. These databases are managed by administrators and are usually hosted on institutional servers. While centralized systems are easy to manage, they have major security risks. If a hacker gains access to the server, sensitive student information can be modified or stolen. Furthermore, centralized systems do not provide a reliable way to verify whether the certificate has been altered. This increases the risk of fake certificates and academic fraud. The system also requires continuous maintenance and infrastructure investment, which increases operational cost. Since data changes may go unnoticed, there is a lack of transparency and trust in the system. Coming to the proposed system introduces a blockchain based online examination and certificate management platform deployment on Ethereum. Smart contracts are developed using Solidity to store or retrieve students' data securely. In the system, each student's exam results and certificate credentials is stored as a blockchain transaction. Every transaction generates a unique cryptographic hash which ensures immutability. If any record is altered, the hash changes automatically and tampering is immediately detected. This system consists of separate modules for student and administrators. Students can register, log in, write exams, view grades, and verify certificates. Administrators can log in, view registered students, check grades, and upload certificates to the blockchain. To reduce transaction cost associated with storage large files on blockchain, certificate images are stored in IPFS while only the hash reference is stored in the blockchain. This approach significantly reduces storage cost while maintaining security and traceability. Additionally, an AI-based algorithm analyzes students' grade and provides suggestions such as good, average, or excellent performance to help improve academic outcomes. Coming to the extension, we have two different extensions. Among them, the first extension concepts involve integrating artificial intelligence into the blockchain-based education system. The AI algorithm evaluates student grades and provides performance suggestions. These suggestions help both students and administrators identify area of improvement. By analyzing exam results, the system can classify performance levels and recommend corrective actions. The second extension concept focuses on reducing blockchain transaction cost. Since blockchain charges fees based on transaction size and storage, storing large certificate image directly on the blockchain can be expensive. To solve this issue, large files such as certificate images are stored in IPFS and only the file's hash addresses are stored in the blockchain. When needed, the certificate can be retrieved using the stored hash. This hybrid blockchain IPFS module reduces cost while maintaining security and immutability. Coming to the modules, first we have admin login. The admin login module allows the administrator to securely access the system using a username and password. This module ensures that only authorized personnel can manage student records, view grades, and upload certificates. Proper authentication is required before accessing administrative features, which enhances system security and prevent unauthorized modifications. Next, view registered students. The View Register Student module enables the administrator to see the list of the students who have registered in the system. The student details are retrieved from the blockchain network, ensuring that the data displayed is authentic and tamper-proof. This module helps the admin monitor user registrations and maintain transparency in student enrollment records. Next, View Grades. The View Grades module allows the administrator to access the exam results of all students. These grades are stored in blockchain transaction, making them immutable and verifiable. In addition, the system integrates an AI-based analysis that evaluates student performance and provides suggestions such as good, average, or excellent. This helps administrator understand overall academic performance and identify students who may need improvement. Next, Upload Certificate. The Upload Certificate module enables the administrator to issue and store student certificates securely. When a certificate is uploaded, its data is stored in the blockchain and a unique cryptographic hash is generated. This hash ensures the certificate cannot be altered without detecting. Large certificate images are stored in IPFS, where the hash reference is saved on the blockchain to reduce storage cost. This module ensures certificate authenticity and long-term security. Next, storage graph. The storage graph module visually represents the cost comparison between storing large data directly on the blockchain and outsourcing it to IPFS. It shows how transaction cost vary depends on storage methods. This module helps demonstrate that using IPFS for large files significantly reduces blockchain transaction expenses while maintaining data security. Next, new user registration. The new user registration module allows new students to create an account in the system. Students enter their personal and login details, which are then stored securely on the blockchain. Once registered, the data becomes immutable and traceable. This module ensures secure onboarding of students into the platform. Next, students login. The students login module enables registered students to access the system using their credentials. After successful authentication, students can write exams, view grades, and verify certificates. This module ensures that only authorized users can access their personal academic records. Next, Write Exam. The Write Exam module allows the student to attempt an online examination. The system presents multiple choice questions, and once the students submit the answers, the grade is automatically calculated. Each student is allowed to attempt the exam only once. The obtained grade is scored as a blockchain transaction, ensuring that the results cannot be modified later. Next, View Your Grades. The View Your Grades module enables students to see their examination results in detail. It displays correct and incorrect answers along with the total percentage. The integrated AI algorithm analyzes the performance and provides suggestions such as good, bad, or excellent. This helps students understand their strengths and weaknesses. Next, check and verify credentials. This module allows students to verify the authenticity of their certificates. The system compares the original stored hash values with the current certificate hash values. If both matches, the certificate is valid. If not, it indicates tampered. This feature ensures secure and trustworthy certificate verification. Next, smart contract deployment. The smart contract deployment module handles the creation and deployment of blockchain smart contract on Ethereum. These smart contracts contain functions to store and retrieve student details, grades, and certificate information. Once deployed, the contract address is used in the Python backend to interact with the blockchain. Next, IPFS execution. The IPFS execution module starts the IPFS server for decentralized file storage. Instead of storing large certificates images directly on the blockchain, they are stored in IPFS and only the file's hash addresses is saved in the blockchain. This reduces storage costs while maintaining secure and decentralized access to files. Coming to the requirements, hardware requirements consisting of operating systems Windows only, processor i5 and above, RAM 8 GB and above, ROM 25 GB and above. Software requirements consisting of Python 3.7.2, Node.js 18.17.1, and Visual Studio Community version. Backend languages which we have used are Python, JavaScript, and Solidity. Framework we used Flask, and front-end languages are HTML, CSS, JavaScript, and Bootstrap 4. To execute the project, first we need to open the code folder which contains the project source code files. Hello It folder. The Hello It folder usually refers to a basic Ethereum project folder created to test and demonstrate simple Ethereum functionality. It typically contains a smart Solidity file, a deployment script, and configuration files such as tuffle configure and package.json needed to compile and deploy the contracts. Education transformation folder. This is the main project code folder. In this, we have the files related to the project. Static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. Templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. App.py file. This .py file contains the information related to front-end logic. It could include code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. Coming to the execution of the project, first, you need to open the Hello It folder, then node modules, then .bin, and double-click on Run bat file so that the tuffle will start develop, and then we need to migrate the tuffle with the command tuffle migrate so that the contracts has been generated. Now minimize this and go to the main project code folder and now click on start IPFS bat file. IPFS stands for Interplanetary File System. It is a decentralized file storage and sharing system that works on peer-to-peer network instead of a central server. An IPFS server is not a traditional server like a normal one. Web hosting. In IPFS, every computer that runs the IPFS software becomes a node, and each node can store and share files with another node in the network. When we run the command IPFS daemon, it starts the IPFS server in the background, and the message daemon is ready appears. It means your IPFS node is successfully running, connected to the network, and ready to upload, download, and share files. Without running the daemon, your system cannot communicate with other IPFS nodes. So file sharing will not work. Minimize this and now copy the path of the code folder from the address bar of the file explorer. Then open command prompt. Use the command cd followed by a space and then paste the copied path. This command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py in command prompt. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address with the port number of 5000. Copy the local link which is provided by the Flask framework and open it in any web browser. I prefer Chrome. So now the home page has been displayed. This is the front end built using the Flask framework. In this page, we have home button, admin login button, student login button, and new user register here button. Firstly, click on new user register here button so that the new user sign up screen will be open where you need to enter the details and create an account for user authentication like username, password, and contact number. Then click on registered so that all the given details are stored, which means the registration has been successfully completed. Here it's clearly given. All the details are stored in hash address. Then click on student login button so that student login screen will be open where you need to enter the details like username and password to log in the application. Click on login. So the user is set to the login. When the student is successfully logged in, a new page will be displayed. In this page, we have write exams button, view your grades button, check and verify certificate credentials button, and log out button. So firstly, click on start exam or write exam. When you click on this write an exam button, the Python program examiner will open, and here the time remaining is clearly given along with the questions asked, like progress of the questions. Here we have 5 different questions where you can answer. Then click on submit the exam. Here you can see the exam submitted successfully. Like we got 60 percentage, like grade is of 60%, time taken is 43 seconds, and status is completed. The given answers has been stored in blockchain transaction with the help of an hash address. And now click on view all grades button so that your examination grades will be open, like your student name, first question answer is correct or wrong, second question answer is correct or wrong, third is correct or wrong, fourth and fifth. And completed date, here it's clearly given date and time taken and grade. Next, click on check and verify the certificate credentials. As we haven't uploaded anything, it's not showing. Then click on log out. Once the student is completing his or her examination results, they will just log out the application. So then the admin must be logged in with the help of username and password, so that the new page will be opened. In this page, we have view register students button, view grades button, upload certificate button, storage graph button, and logout button. Firstly, click on view registered students button so that how many students are there, like whoever logged in will be shown here clearly. Next, view grades, like what is the grade they have obtained, it's clearly given. And next, upload the certificate. Now, the authority must give the student's name and upload the certificate. Image has been uploaded, and click on upload certificate so that the certificate has been successfully uploaded. And now click on storage graph button so that the graph will be displayed, like blockchain versus IPFS outsourced transaction cost graph. Here we have blockchain cost, like 80% of Ethereum, IPFS cost is 60 Ethereum, cost saving is 25%. We also have the key insights of the graph. And then click on log out. Finally, the project successfully demonstrates how blockchain technology can enhance security, transparency, and trust in educational record management by deploying the system on Ethereum and integrating IPFS for cost-efficient storage. The solution ensures tamper-proof grade and certificate management. The addition of AI-based performance analysis further improves academic evaluation overall. The system provides a secure, decentralized, and scalable approach to modernization education data management. Next, click on student login. Once again, just log in as a student. As the admin has entered the certificate, now let us check and verify the certificate credentials. So Vandana, hash code, and certificates had been uploaded and verification status is successful. Then click on logout. This is all about your project. Thank you.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.